This video will walk through the PV Thinking Cyclogenesis figure. First, let's look at the global PV profile. As you can see, the stratosphere reaches closer to the surface the further north you go. The stratosphere also has a large PV value because the d theta dz term is large as the stratosphere is highly stratified. The troposphere, however, is very well mixed and thus has smaller PV values. Therefore, it can be assumed that any northerly flow will bring about positive PV anomalies and any southerly flow will bring about negative PV anomalies. So let's start with a positive PV anomaly at the tropopause. This PV anomaly will induce a cyclonic flow that will extend towards the surface, decreasing in magnitude as it distances from the PV anomaly. Now you can see that there are northerly and southerly flows induced at the surface. These flows will induce warm and cold surface anomalies. The warm surface anomaly will induce a cyclonic flow that will stretch up towards the tropopause, and the cold surface anomaly will induce an anticyclonic flow that will also stretch up towards the tropopause. Now it can be seen that there are southerlies and northerlies that have been induced aloft by these temperature anomalies at the surface. Thinking back to the global PV profile, it can then be seen that the southerlies aloft will produce a negative PV anomaly at the tropopause, and the northerlies will enhance the original PV anomaly that began the system in the first place. It is also known that the cold and warm surface anomalies will act as negative and positive PV anomalies respectively. Now it can be seen that there is a westward tilt of PV with height, and a westward tilt of PV with height indicates cyclogenesis, because as long as the system is in phase, the cycle will just continue to amplify the original PV anomaly, which will then in turn amplify everything else, including your surface low where the warm temperature anomaly is.